February 26, 1991. The Kuwaiti Desert. An Iraqi T-72 tank crew sat inside their Soviet-made machine, scanning the darkness through crude night vision optics. They were part of Iraq's Republican Guard, the elite of Saddam Hussein's military, equipped with what was supposed to be one of the world's most formidable tanks. 2 kilometers away, an American M1 Abrams tank crew detected them instantly through thermal imaging that turned night into day. The Iraqi crew never saw what killed them. The Abrams 120mm gun fired once. The sabot round traveled at over a mile per second. The T-72 exploded, its turret blown 20 feet into the air by catastrophic ammunition detonation. This scene repeated hundreds of times during the Gulf War. American M1 Abrams tanks destroyed Iraqi armor with such one-sided efficiency that it barely qualified as combat. It was execution. But rewind a decade. The mid-1980s. Moscow, GRU headquarters. Soviet military intelligence officers gathered around a conference table, reviewing classified reports on NATO's newest main battle tank. Photographs showed a massive, angular vehicle weighing 70 tons. Technical specifications revealed a gas-turbine engine that consumed fuel at staggering rates. The armor was some new composite material the West called Chobham, British-American collaboration whose exact composition remained classified. One Soviet general studying the reports shook his head dismissively. It's overweight, overengineered. The Americans have built a tank that requires a supply convoy just to keep it running. Look at this fuel consumption. It will run dry before it reaches the battlefield. Another officer agreed. They've sacrificed everything for technology. Our T-72 is simple, reliable, producible. We can build 10 for every one of these American monsters. Quantity defeats quality. Always has. A third analyst added his assessment to the growing consensus. The turbine engine will break down in field conditions. The sophisticated fire control will fail. The complexity makes it unsuitable for prolonged combat operations. This tank represents typical Western excess. Impressive on paper, useless in war. Soviet propaganda magazines ran articles mocking the M1 Abrams. Political cartoons showed it stuck in mud, out of fuel, too heavy to cross bridges. The message was clear. The Americans had wasted billions on a technological white elephant that would never survive real combat. Western defense analysts weren't much more optimistic. Journalists called it the gas-guzzling Abrams. Cost overruns plagued development. Early training accidents raised questions about reliability. Even some American military officers wondered whether simpler, cheaper tanks might be more practical. They were all wrong. Catastrophically wrong. The M1 Abrams didn't just survive real combat. It dominated it so completely that it redefined what modern tank warfare looked like. And in the process, it helped bury the Soviet military doctrine that had mocked it. This is the story of how American engineers built a tank the Soviets said was impossible, how Soviet generals dismissed it as impractical, and how a few days in the Iraqi desert proved that sometimes technological superiority matters more than numbers. To understand why the M1 Abrams represented such a revolutionary design, you need to understand the tank warfare landscape of the 1970s. The United States Army's main battle tank was the M60 Patton, a capable design from the 1960s but increasingly outmatched by Soviet armor developments. The M60 had a 105mm gun, conventional steel armor, and mechanical fire control systems. It was reliable and well understood, but it was also outdated. Meanwhile, the Soviet Union was producing revolutionary tank designs at a pace NATO couldn't match. The T-64 introduced composite armor and an automatic loader that reduced crew from 4 to 3. The T-72, entering mass production in the 1970s, combined improved armor, a powerful 125mm smoothbore gun, and production simplicity that allowed the Soviets to build thousands at relatively low cost. By the mid-1970s, intelligence estimates suggested the Warsaw Pact had a 3-to-1 advantage in tanks stationed in Eastern Europe. Some estimates put Soviet tank numbers even higher. NATO war games consistently showed that in a conventional conflict, Warsaw Pact armor would overwhelm Western defenses through sheer numbers. This created an existential problem for NATO military planners. How do you defend against an enemy that can field 3 tanks for every one of yours? The traditional answer was tactical nuclear weapons. Use nukes to destroy massed armor formations. But this strategy meant any European war would quickly go nuclear, with catastrophic consequences. The alternative was to develop tanks so technologically superior that each one could destroy multiple enemy vehicles before being destroyed itself. Quality over quantity. But this required revolutionary advances in armor protection, firepower, and fire control systems. The U.S. Army and West Germany initially collaborated on the MBT-70 program, attempting to jointly develop a next-generation tank. It was an ambitious project featuring a 152mm gun launcher, sophisticated stabilization, and advanced armor. It was also a disaster. Cost overruns plagued the program. Technical problems proved intractable. Requirements conflicts between American and German engineers caused delays. By 1971, the project was billions over budget with no operational tank to show for it. Congress canceled American participation. The program collapsed. But the requirement remained. The U.S. Army desperately needed a new tank. They initiated an independent American program called M1, which would eventually become the M1 Abrams, named after General Creighton Abrams, a distinguished tank commander from World War II and Vietnam. The requirements were ambitious to the point of seeming impossible. The new tank needed to defeat any Soviet tank at ranges beyond what Soviet tanks could effectively engage. It needed armor capable of withstanding direct hits from Soviet 125mm guns. It needed to operate at night as effectively as during day. It needed mobility to match or exceed Soviet armor. And it needed to be reliable enough for sustained combat operations. 2 contractors competed for the contract, Chrysler Defense and General Motors. Both submitted radical designs that departed significantly from conventional tank architecture. Chrysler's design, which would ultimately win, featured the most controversial component, a gas turbine engine. Most tanks used diesel engines, proven, reliable, fuel-efficient. Chrysler proposed using a Honeywell AGT 1500 turbine, an engine type more commonly found in helicopters and ships. The turbine offered enormous advantages. It was more compact than a diesel engine of equivalent power, allowing more space for armor and ammunition. It was much quieter, crucial for tactical operations. It could accelerate the 70-ton tank from 0 to 20 mph in just 7 seconds. Extraordinary mobility for such a massive vehicle. And it could run on multiple fuel types, diesel, gasoline, jet fuel, providing logistical flexibility. But turbines also had disadvantages that critics seized upon. Fuel consumption was approximately twice that of a diesel engine. The tank would need frequent refueling, requiring extensive logistical support. Early turbines had reliability concerns. They were sensitive to dust and debris, and they were expensive compared to conventional diesel engines. Soviet intelligence obtained details of the XM1 program through espionage and open-source analysis. Their assessment was skeptical. The turbine engine was seen as a critical vulnerability. High fuel consumption would limit operational range and place enormous strain on supply lines. The sophisticated fire control systems were dismissed as prone to battlefield failure. The advanced armor was unknown in composition, but Soviet engineers were confident their 125mm guns could defeat it. In 1980, the first production M1 Abrams tanks rolled off the assembly line at the Lima Army Tank Plant in Ohio. They cost approximately $2.5 million each in 1980 dollars. Expensive, but not outrageously so given the sophisticated technology packed inside. The Soviet response was to accelerate T-80 production and begin design work on improvements. They weren't worried. Their doctrine emphasized that quantity and tactical proficiency would overcome Western technological advantages. That doctrine was about to be tested in the deserts of Iraq and Kuwait, and it would fail catastrophically. The M1 Abrams that emerged from Chrysler Defense's design team was unlike any tank previously built. Every major system represented a departure from conventional design philosophy. Start with the armor. The Abrams used a revolutionary armor package developed jointly by British and American researchers, called Chobham armor after the British research facility where much of the work was done. The exact composition remains classified today, but it consists of multiple layers of different materials, steel, ceramics, plastics, and other compounds, arranged to defeat both kinetic energy penetrators and shape-charge warheads. Traditional steel armor worked through thickness. The thicker the steel, the more protection. But thickness meant weight, and weight limited mobility. Chobham armor provided equivalent or better protection at lower weight by using materials specifically optimized to defeat different threat types. Ceramics shattered incoming penetrators. Composite layers dissipated shape-charged jets. The result was armor that could withstand hits that would destroy any previous tank. The turret and front hull were encased in this composite armor, making the Abrams nearly impervious to frontal attacks. The sides and rear remained vulnerable. No tank can be heavily armored everywhere without becoming immobile, but the frontal protection was extraordinary. Firepower came from a 105mm M68 rifled gun in initial models, the same gun used in the M60, but with significantly improved ammunition. Later models upgraded to a German-designed Rheinmetall 120mm smoothbore gun, one of the most powerful tank guns ever deployed. The 120mm could fire multiple ammunition types: armor-piercing, fin-stabilized, discarding sabot rounds for killing tanks, high-explosive anti-tank rounds for lighter vehicles and bunkers, and various specialized munitions. But the gun was only part of the firepower equation. What made the Abrams truly revolutionary was its fire control system. Previous tank gunnery relied on the gunner's skill to estimate range, calculate lead for moving targets, and adjust for wind and barrel wear. It was complex, difficult, and required extensive training. Experienced gunners could achieve impressive accuracy, but combat stress and battlefield conditions degraded performance significantly. The Abrams fire control system computerized almost everything. A laser rangefinder provided instant, accurate distance to target. The ballistic computer calculated the necessary aim point accounting for range, target movement, vehicle movement, wind, temperature, barrel wear, and ammunition type. The gunner simply placed the crosshairs on the target, lased for range, and fired. The computer did the rest. The gun stabilization was equally sophisticated. Hydraulic and electronic systems kept the gun pointed at the target even while the tank was moving at high speed over rough terrain. Previous tanks had to stop, or at least slow significantly, to fire accurately. The Abrams could fire accurately at full speed. Combined with thermal imaging sights, this fire control system gave Abrams crews an overwhelming advantage. They could detect enemy tanks at ranges of 3 to 4 kilometers using thermal imaging that saw through darkness, smoke, and dust. They could accurately engage targets at ranges exceeding 2 kilometers while moving at 30 miles per hour. Soviet tanks had none of these advantages. T-72s used optical rangefinders that were slow and inaccurate. Their fire control was mechanical, requiring manual calculations. Their night vision equipment was primitive infrared systems with limited range. They had to stop or slow dramatically to fire accurately. Mobility came from that controversial gas turbine engine. The Honeywell AGT 1500 produced 1,500 horsepower, giving the 70-ton Abrams a power-to-weight ratio of about 21 horsepower per ton, comparable to much lighter vehicles. The tank could reach 42 miles per hour on roads and 30 miles per hour cross-country. It could climb 60% grades and traverse rough terrain that would stop conventional tanks. The turbine's quietness provided a tactical advantage that Soviet analysts underappreciated. Diesel tanks could be heard from considerable distances. The Abrams turbine was much quieter, especially at idle. Iraqi crews during Desert Storm reported being shocked when Abrams tanks appeared seemingly from nowhere. They simply hadn't heard them approaching. The crew consisted of 4: commander, gunner, loader, and driver. Unlike Soviet tanks which used auto-loaders, the Abrams retained a human loader who could sustain a fire rate of about 6 rounds per minute under ideal conditions. This decision was controversial. Auto-loaders reduced crew requirements and allowed smaller turrets, but human loaders proved more flexible and reliable in combat conditions. The crew compartment was separated from ammunition storage by blast doors. If the ammunition was hit, the explosion would vent upward through blowout panels rather than into the crew compartment. This design philosophy, prioritizing crew survival, differed from Soviet approaches which accepted higher crew casualty rates. Early operational experience with the Abrams was mixed. The turbine engine, while powerful, did indeed consume fuel voraciously, about 2 gallons per mile under typical conditions, worse in combat. The sophisticated systems required extensive maintenance. Air filters needed frequent cleaning in dusty environments. The electronics were sensitive to rough handling. Training accidents occurred as crews learned to handle the massive, fast tank. Several Abrams were damaged or destroyed in non-combat incidents during the 1980s. These incidents reinforced Soviet skepticism that the Abrams was too complex for field operations. But these were teething problems, typical of any revolutionary design. As crews gained experience and maintenance procedures were refined, reliability improved dramatically. By the late 1980s, the Abrams had matured into a formidable weapons system. Soviet intelligence continued monitoring the Abrams program. They noted the improvements, the increasing numbers entering service, the training emphasis. Their assessments remained dismissive but with a hint of uncertainty. The Abrams had never faced combat. Its theoretical advantages were just that, theoretical. Only battle would prove whether American technological sophistication could overcome Soviet numerical advantage in combat-proven designs. That battle was coming, and it would shock the world. Inside Soviet military intelligence headquarters on Moscow's Kodinka airfield, analysts spent the 1980s studying NATO armor developments with particular focus on the M1 Abrams. Their assessments, some now declassified, reveal a mixture of respect for American engineering and confidence in Soviet tactical doctrine. A 1984 GRU, Soviet Military Intelligence, assessment obtained through archives provides remarkable insight into Soviet thinking. The document analyzed the Abrams comprehensively, noting its strengths while emphasizing what Soviet analysts perceived as critical weaknesses. On armor protection, the assessment acknowledged that Chobham composite armor represented a significant advance. However, Soviet analysts believed their 125mm smoothbore gun firing improved ammunition could defeat it at combat ranges. They noted that Soviet anti-tank guided missiles, particularly the 9M119 reflex, should be effective against even heavily armored targets. The turbine engine received particular attention. Soviet analysts calculated fuel consumption rates and concluded the Abrams would require refueling after approximately 120 kilometers of combat operations, less under high-intensity conditions. They assessed this as a critical vulnerability. The M1's operational radius is severely limited by fuel requirements. In sustained combat operations, American logistics will struggle to maintain adequate fuel supply to forward units. This limitation makes the M1 unsuitable for deep penetration operations or prolonged engagements. This assessment wasn't wrong about fuel consumption. The Abrams did require extensive logistical support. But Soviet analysts underestimated American logistics capabilities and overestimated how much this vulnerability would matter in actual combat. The fire control system impressed Soviet analysts more than they publicly admitted. The laser rangefinder and ballistic computer represented capabilities Soviet tanks lacked. A classified Soviet military journal article from 1985 noted, NATO's integration of advanced fire control systems provides significant first-shot kill probability advantages. Our current generation tanks are disadvantaged in long-range gunnery duels. This honest internal assessment contrasted sharply with public Soviet statements, which continued emphasizing the superiority of Soviet armor. But the GRU knew the Abrams represented a serious challenge. Soviet tank design philosophy differed fundamentally from the American approach. Where American designers prioritized crew survivability, firepower, and individual tank effectiveness, Soviet designers emphasized production efficiency, tactical flexibility, and accepting higher loss rates as acceptable if objectives were achieved. The T-72, the Soviet Union's most numerous tank during the 1980s, embodied this philosophy. It was simpler to manufacture than the Abrams, requiring fewer machining hours and less sophisticated components. The autoloader reduced crew to 3, allowing a smaller, lighter turret. The suspension and running gear were rugged and easy to maintain. But the T-72 made compromises that would prove catastrophic in combat. The autoloader stored ammunition in a carousel beneath the turret crew compartment. If this ammunition was hit, the explosion would almost certainly kill the entire crew and blow the turret off the hull. A signature T-72 death that would become grimly familiar during Desert Storm. The fire control was primitive by Western standards. Optical rangefinders required the gunner to manually estimate range by adjusting focus until the target appeared sharp. This process was slow and inaccurate, particularly under combat stress. The mechanical ballistic computer required manual input of environmental conditions. The gun stabilization was inferior to the Abrams, reducing accuracy while moving. Night vision equipment was particularly limited. Soviet tanks used infrared searchlights and passive infrared viewers. The searchlights were visible to enemy night vision equipment, essentially advertising the tank's position. The passive viewers had limited range and poor resolution. Against Abrams' thermal imaging, which required no illumination and saw through darkness as clearly as daylight, Soviet night vision equipment was generationally obsolete. Soviet military doctrine counted on compensating for these individual disadvantages through numbers and tactics. Warsaw Pact planning called for massive armor concentrations that would overwhelm NATO defenses through sheer weight of numbers. Soviet tank battalions would accept high casualties if they achieved breakthrough. Once through NATO lines, Soviet armor would exploit deep into Western Europe, disrupting logistics and preventing organized defense. This doctrine had historical precedent. Soviet experiences in World War II emphasized mass attacks, accepting heavy losses to achieve strategic objectives. The Soviet military-industrial complex was organized to produce huge numbers of tanks rapidly. Quality mattered less than quantity. NATO intelligence, observing Soviet armor development, was genuinely concerned. The T-72 appeared to be an effective design, produced in enormous numbers, supported by a tactical doctrine that might overcome NATO technological advantages through mass. American war games consistently showed NATO forces being overwhelmed by Warsaw Pact armor attacks. This mutual misassessment, Soviets underestimating Western technology, NATO overestimating Soviet capabilities, created a situation where both sides expected different outcomes from tank combat than what would actually occur. Soviet propaganda in the 1980s emphasized the superiority of Soviet arms. Military parades showcased new tank variants. Publications praised Soviet engineering efficiency versus wasteful Western excess. The message to Soviet citizens and the world was clear. Soviet armor was more than capable of defeating NATO forces. But behind closed doors, some Soviet military leaders harbored doubts. General Valentin Varenikov, deputy chief of the Soviet General Staff in the 1980s, later admitted, "We knew NATO was advancing technologically faster than we could match. Our response was to emphasize what we had: numbers, tactical proficiency, and our soldiers' fighting spirit. But we worried about the technology gap." The Iraq-Iran War in the 1980s provided some combat data. Iraqi T-72s faced Iranian armor in large battles. The results were mixed. T-72s proved effective but not invulnerable. However, both Iraq and Iran were using export model tanks and employing questionable tactics. Soviet analysts discounted these results as not representative of how Soviet-trained forces would perform. Then came 1990. Iraq invaded Kuwait and seized a country defended by a small Kuwaiti force. Saddam Hussein, emboldened by his army's size and equipped with Soviet weapons, refused to withdraw. A U.S.-led coalition began deploying forces to Saudi Arabia. Soviet observers watched with interest. Finally, after decades of theoretical debates and war games, American and Soviet armor designs would face each other in combat. Not directly. The Iraqis weren't Soviets, but Iraqi forces used Soviet equipment and Soviet doctrine. It would be the closest thing to a NATO Warsaw Pact tank battle the world had ever seen. Soviet military intelligence predicted Iraqi forces would inflict significant casualties on coalition forces before being defeated. They didn't expect Iraq to win. The coalition was too strong. But they expected Soviet weapons to perform respectably, maintaining the Soviet Union's reputation as an arms exporter. What happened instead would shake Soviet military confidence to its core. January 17, 1991. Operation Desert Storm began with a massive air campaign targeting Iraqi command and control, air defenses, and military infrastructure. For 5 weeks, coalition aircraft systematically destroyed Iraqi capability to coordinate military operations. On February 24th, the ground war began. The coalition plan called for a massive flanking maneuver. While Marines and Arab coalition forces attacked Iraqi positions in Kuwait directly, U.S. Army heavy divisions would sweep through the western desert into Iraq, then turn east to attack Republican Guard forces from the side and rear. It was a left hook on a strategic scale, designed to bypass Iraqi defenses and destroy their best units in open terrain. The U.S. 7th Corps, commanded by Lieutenant General Frederick Franks, spearheaded this attack. The Corps included the 1st and 3rd Armored Divisions and the 1st Infantry Division, mechanized, equipped with M1 Abrams tanks, an improved model with the 120mm gun and upgraded armor. Iraqi forces occupying Kuwait and southern Iraq numbered approximately 500,000 soldiers, including Republican Guard armored divisions equipped with T-72s, T-62s, and T-55s. These were Iraq's best forces, professional soldiers with combat experience from the 8-year war with Iran. The Iraqi defensive plan relied on fixed positions, minefields, and artillery. Iraqi commanders expected coalition ground forces to attack directly into prepared defenses, where Iraqi armor would fight from fortified positions supported by artillery. This was a Soviet-style defensive doctrine that had worked reasonably well against Iran. But that's not what happened. Coalition forces entered Iraq and immediately outpaced Iraqi ability to respond. The Abrams tank's mobility, capable of sustaining 30 miles per hour across desert terrain, allowed American forces to advance faster than Iraqi intelligence could track. Iraqi defensive positions found themselves outflanked before they could adjust. The first major tank engagement occurred on February 26th at a location that would become legendary, 73 Easting. The 2nd Armored Cavalry Regiment, screening ahead of 7 Corps main forces, encountered the Tawakalna Division of the Republican Guard. What followed was the most one-sided tank battle in history. The engagement began around 4 p.m. during a blinding sandstorm. Visibility was near zero. Neither side could see more than a few hundred meters. But American forces didn't need to see. Their thermal imaging saw through sand, dust, and darkness as if they weren't there. Captain H.R. McMaster, commanding Eagle Troop of the 2nd Armored Cavalry Regiment, led a formation of 9 M1 Abrams tanks and 12 M3 Bradley fighting vehicles into the sandstorm. Within minutes, his gunners began detecting Iraqi vehicles through their thermal sights. Iraqi T-72 crews, blinded by the sandstorm and lacking effective thermal imaging, had no idea American forces were present until their tanks started exploding around them. The first Iraqi T-72 was destroyed at 1,420 meters, nearly a mile. The Abrams gunner lazed the target, the fire control system calculated the solution, and the 120mm gun fired. The Sabo round, a dart of depleted uranium traveling at over a mile per second, penetrated the T-72's armor and detonated its ammunition. The turret blew off in the signature catastrophic kill that would characterize T-72 deaths throughout the war. The kill ratio was stunning. American tanks were destroying Iraqi armor at ranges where Iraqi crews couldn't effectively return fire. The combination of superior thermal imaging, fire control, and armor protection created an engagement envelope where only one side could fight effectively. Captain McMaster later described the battle. They never had a chance. We could see them perfectly through our thermals. They couldn't see us at all. It wasn't combat, it was execution. The Battle of 73 Easting continued into the night. When dawn broke on February 27th, the battlefield revealed the scope of Iraqi losses. Over 70 armored vehicles destroyed, including T-72s, T-55s, MTLBs, and trucks. American losses: 0 tanks destroyed by enemy fire. 1 M3 Bradley damaged. This pattern repeated across the front. At the Battle of Medina Ridge on February 27th, the 1st Armored Division's 2nd Brigade encountered the Medina Division of the Republican Guard. In just 90 minutes of fighting, American forces destroyed over 186 Iraqi armored vehicles while losing 0 tanks to enemy fire. At Norfolk, at Objective Dorset, at Phase Line Bullet, every major engagement told the same story. American M1 Abrams tanks destroyed Iraqi armor at ranges of 2,000 to 3,000 meters. Iraqi return fire, when it occurred at all, was ineffective. T-72s scored hits on Abrams, but the hits didn't penetrate. The Chobham armor that Soviet analysts had believed could be defeated proved effectively impervious to Iraqi 125mm rounds. The thermal imaging advantage was so overwhelming that it almost seemed unfair. Iraqi crews reported that American tanks would appear from nowhere, destroy Iraqi vehicles, and disappear before effective return fire was possible. Night operations, which should have provided some equality, instead became complete dominance for American forces. One Iraqi tank commander who survived later described his experience. "We heard explosions. Tanks around us were burning. We fired at where we thought the Americans were, but hit nothing. Then our tank was hit. I don't know what from. I never saw the enemy until I was surrendering." The fuel consumption that Soviet analysts had identified as the Abrams' critical weakness proved manageable. American logistics, organized to support mobile armored operations, kept fuel flowing to forward units. M1 Abrams tanks ran continuously for days, refueling from tanker trucks without operationally significant delays. The few Abrams losses that occurred were instructive. Approximately 18 M1A1s were knocked out during Desert Storm. Of these, 9 were destroyed by friendly fire, American aircraft or other American tanks in the confusion of rapid mobile warfare. 7 were disabled by Iraqi fire but recovered and repaired. Only 2 were permanent losses, both recovered later. Not a single M1A1 Abrams was destroyed by Iraqi T-72s. Iraqi tank rounds penetrated Abrams armor in a handful of cases when they struck vulnerable areas, side, rear, or turret ring, but even these penetrations rarely resulted in complete tank losses. The crew compartment separation from ammunition storage meant even penetrations often didn't cause catastrophic explosions. The Iraqi side suffered catastrophic losses. Post-war assessments estimated between 3,000 and 4,000 Iraqi tanks were destroyed or captured during the conflict. Many were abandoned without being engaged. Iraqi crews simply fled when they realized combat was futile. Others were destroyed by air power. But hundreds were killed in direct tank engagements, and the results were horrifically one-sided. A 1st Armored Division report noted, "In multiple engagements, we achieved first-round hits at ranges exceeding 2,500 meters while moving at tactical speeds. Enemy return fire, when present, was uniformly inaccurate and ineffective. Our thermal sights and fire control system provided overwhelming advantages in all conditions, day, night, and during the sandstorm." By February 28, just 100 hours after the ground war began, President George H.W. Bush declared a ceasefire. Iraqi forces in Kuwait had been routed. The Republican Guard divisions had been shattered. The coalition had achieved total victory at a cost in American casualties that was astonishingly low. The M1 Abrams had proved untouchable. Soviet analysts' predictions that the tank was too complex, too fuel-hungry, too sophisticated for real combat had been disproven in the most definitive way possible. The Abrams hadn't just survived combat. It had dominated so completely that tank warfare had been redefined. Moscow, March 1991. Soviet military headquarters was reeling from what they'd witnessed in Iraq. Soviet military observers had been stationed with Iraqi forces before the war. They'd evacuated before Desert Storm began, but they'd studied Iraqi defensive preparations and equipment. They provided technical advice and training. And now they watched in shock as Soviet-equipped Iraqi forces were annihilated by American armor. The Soviet General Staff convened emergency assessments to analyze the Gulf War results. The conclusions were sobering and, for some senior officers, devastating to their worldview. A declassified summary of these discussions, published years later in Russian military journals, reveals the depth of Soviet concern. The conflict in the Persian Gulf demonstrated that NATO, particularly American, forces possess technological advantages in armored warfare that exceed our previous estimates. The combination of thermal imaging, advanced fire control, and composite armor provides Western main battle tanks with capabilities against which our current generation armor is severely disadvantaged. The specific performance of the M1 Abrams shocked Soviet analysts. They'd predicted Iraqi T-72s would inflict significant casualties even in a losing campaign. Instead, Iraqi armor had been destroyed with near impunity. The engagement ranges at which American tanks achieved kills, routinely exceeding 2,000 meters, were beyond what Soviet doctrine considered effective tank combat range. Soviet fire control doctrine assumed tank engagements occurred at 1,000 to 1,500 meters, where both sides would have reasonable hit probabilities. At these ranges, superior numbers could compensate for individual technical disadvantages. But American thermal imaging and fire control extended effective engagement range beyond 2,500 meters, where Soviet-equipped tanks couldn't fight effectively. General Pavel Grachev, who would become Russia's defense minister in 1992, later wrote about the Gulf War's impact. We realized that in a hypothetical NATO-Warsaw Pact conflict, our armored forces would face similar disadvantages to those the Iraqis experienced. Our tanks, which we had believed were adequate to their task, were revealed to be generationally obsolete in key areas. This was a difficult realization. The thermal imaging gap was particularly concerning. Soviet military industry had struggled to produce effective thermal imaging systems for tanks. The T-80, the Soviet Union's most advanced tank in 1991, had primitive night vision equipment compared to Western thermal sights. Research programs existed to develop better systems, but they were years behind Western capabilities. Soviet military journals in 1991 and 1992 published unusually frank assessments of armor capabilities. One article in Voyenaya MySel, Military Thought, the Soviet General Staff's theoretical journal, analyzed Desert Storm and concluded, the technological advantages demonstrated by American armored forces cannot be overcome solely through tactical proficiency or numerical superiority. Our response must include substantial investments in fire control, sensors, and crew protection if we are to maintain competitive parity. But the Soviet Union in 1991 was in no position to make substantial investments in anything. The economy was collapsing. The Communist Party was losing control. By December 1991, the Soviet Union itself would dissolve. The military-industrial complex that had produced thousands of T-72s was being dismantled. The Russian Federation inherited Soviet military assets, but not Soviet military budgets. Throughout the 1990s, Russian defense spending plummeted. New tank production nearly stopped. Research programs were suspended or dramatically scaled back. The Russian military struggled to maintain existing equipment, let alone develop new systems. What development did occur focused on upgrading existing platforms. The T-90, introduced in 1992, was essentially an upgraded T-72 with improved armor, including contact, 5 explosive reactive armor, better fire control, and slightly improved sensors. It was an incremental improvement, not a revolutionary design. Russian engineers also developed new ammunition types designed specifically to defeat Western composite armor. The 3BM-42 Mango and 3BM-59 lead armor-piercing rounds used longer penetrators and improved materials to increase penetration capability. Russian claims suggested these rounds could defeat M1 Abrams frontal armor, though this was never tested in combat. The psychological impact of Desert Storm on Soviet/Russian military thought was profound. For decades, Soviet doctrine had emphasized that quantity, tactical skill, and fighting spirit could overcome Western technological advantages. Desert Storm demonstrated that this assumption was dangerously wrong. Technology gaps of sufficient magnitude couldn't be overcome through traditional military virtues. This realization contributed to broader questioning of Soviet military doctrine that accelerated during the 1990s. If Soviet tanks were obsolete, what about Soviet air defense systems? Artillery? Infantry equipment? The entire Soviet military-industrial model, which prioritized mass production of adequate equipment over smaller numbers of excellent equipment, seemed questionable in light of Gulf War results. Western intelligence assessments of the Gulf War's impact on Soviet military thinking noted the concern and uncertainty. A 1992 CIA report stated, "The performance of U.S. forces in Desert Storm has caused significant reassessment within the former Soviet military establishment. We assess that Soviet/Russian confidence in their conventional military capabilities has been substantially degraded." China, observing these developments, drew its own conclusions. Chinese military planners studied Desert Storm intensively and concluded that their own military, equipped largely with Soviet-derived weapons, would face similar disadvantages against Western forces. This realization spurred Chinese military modernization programs that continue today. Meanwhile, the M1 Abrams reputation soared. Countries around the world sought to purchase the tank or develop similar capabilities. The Abrams became a symbol of American military superiority, a concrete demonstration that technology and training could overcome numerical disadvantages. American armor doctrine was validated and reinforced. The emphasis on superior sensors, fire control, and crew protection had proven correct in the most definitive test possible: combat against Soviet-designed equipment using Soviet doctrine. Future American armor programs would continue prioritizing these capabilities. The irony wasn't lost on military historians. Soviet generals had mocked the Abrams as overweight, overcomplicated, and unsuitable for combat. Those same characteristics, the sophisticated fire control that required extensive maintenance, the fuel-hungry turbine that demanded robust logistics, the advanced composite armor that increased weight, had proven decisive in actual combat. The gas guzzler that Soviet analysts dismissed as logistically unsupportable had been supplied with fuel so effectively that it never stopped advancing. The sophisticated fire control they predicted would fail in field conditions had worked flawlessly in sandstorms and darkness. The weight they criticized had been supported by American logistics and provided the platform for armor that couldn't be penetrated. Soviet military thinking had been shaped by World War II experiences where quantity often did defeat quality, where mass attacks overwhelmed sophisticated defenses, where simple, reliable equipment beat complicated machinery. But warfare had changed. Technology gaps that might have been manageable in 1945 were decisive in 1991. The M1 Abrams hadn't just won a war. It had obsoleted an entire approach to armored warfare. And the Soviet Union, facing economic collapse and political disintegration, had no capacity to respond effectively. The M1 Abrams Desert Storm performance transformed it from a controversial Cold War weapon into a legend that would define armored warfare for decades. Post-Gulf War, the Abrams underwent continuous upgrades that addressed minor weaknesses while building on proven strengths. The M1A2, introduced in 1992, added a commander's independent thermal viewer, allowing the commander to scan for targets independently of the gunner. Digital systems improved situational awareness through the intervehicular information system, letting tanks share targeting data and positions digitally. The M1A2 System Enhancement Package, SEP, added second-generation thermal imaging with higher resolution. Improved armor packages incorporated lessons from analyzing Iraqi hits. Better ammunition, including the M829A3 depleted uranium penetrator, increased lethality against newer armor types. Each upgrade cycle extended the Abrams' technological edge. By the 2000s, the M1A2 SEP was so advanced compared to the original M1 that they were almost different vehicles, though the basic design remained unchanged. The tank proved its worth again during the 2003 Iraq invasion. Operation Iraqi Freedom saw M1A1 and M1A2 Abrams tanks engage Iraqi armor, again including T-72s, with similarly one-sided results. One engagement near Baghdad saw a single Abrams destroy 7 T-72s in rapid succession. Iraqi crews abandoned their vehicles rather than face American tanks. But Iraq 2003 also revealed new challenges. Urban combat in cities like Fallujah and Baghdad exposed the Abrams to close-range attacks from RPGs, improvised explosive devices, and rocket-propelled grenades fired from buildings. While the frontal armor remained virtually impervious, side and rear armor could be penetrated by well-aimed shots. Several Abrams were destroyed or severely damaged by IEDs, particularly explosively formed penetrators supplied by Iran. These weapons, designed specifically to defeat armor, used shaped charges to form a molten copper slug traveling at extreme velocity. They could penetrate even Abrams armor when properly positioned. The Army responded with the Tank Urban Survival Kit, Tusk, adding reactive armor tiles to the sides, slat armor to the rear, a remote weapon station, and better optics for urban environments. The upgrades helped, but urban combat remained dangerous even for the world's best tank. The Abrams' influence extended beyond American service. Egypt operates over 1,000 M1 A1s, making it the second-largest Abrams fleet in the world. Saudi Arabia, Kuwait, and Australia also purchased the tank. Each operator validated the design's effectiveness, though none faced combat as intense as American forces experienced. Other nations studied the Abrams and incorporated lessons into their own designs. Germany's Leopard 2, Britain's Challenger 2, France's Leclerc, and Israel's Merkava all featured similar emphasis on advanced fire control, thermal imaging, and composite armor. The Abrams had set the standard. Everyone else was catching up. Russia's response came slowly due to economic constraints. The T-14 Armata, unveiled in 2015, represented Russia's attempt to leapfrog Western designs. It featured an unmanned turret with the crew in an armored capsule, active protection systems to intercept incoming rounds, and advanced sensors. But production numbers remain tiny. Financial constraints limit the Russian military to producing only a few dozen per year. China developed the Type 99 series, incorporating composite armor, fire control systems, and an active protection system. Chinese tanks show clear influence from lessons learned studying the Abrams and Desert Storm. The People's Liberation Army studied American armored warfare intensively, building doctrine around similar combined arms integration. The Abrams itself continues evolving. The M1 A2 SCPV-3, entering service in the 2020s, features third-generation thermal imaging, improved networking, better power generation, and ammunition data links. The SCPV-4, currently in development, will add active protection systems, further improved sensors, and more lethal ammunition. Plans exist for developing a successor platform, tentatively called the Abrams X, featuring a hybrid electric drive, reduced crew through automation, lighter weight through new materials, and integrated drone control. But even optimistic timelines suggest any replacement won't enter service until the 2030s at earliest. This longevity is extraordinary. The basic M1 design is over 40 years old. With continuous upgrades, it may serve 70 years or more. Few weapons systems remain competitive for that long. The fact that the Abrams does testifies to how revolutionary the original design was and how effectively upgrades have maintained its edge. The tank's combat record remains unmatched. In over 3 decades of combat operations, Desert Storm, Iraq, Afghanistan, no M1 Abrams has been destroyed by enemy tank fire. Dozens have been lost to mines, IEDs, and anti-tank missiles, but 0 to other tanks in direct combat. This record is unprecedented in modern armored warfare. The cost of maintaining this edge is substantial. Modern M1 A2 SCPV-3 tanks cost approximately $9 million each. Annual operating costs per tank run into hundreds of thousands of dollars. The fuel consumption that Soviet analysts criticized remains a real challenge. The Abrams requires sophisticated logistics to keep running. But the American military accepts these costs because the alternative, fielding inferior armor that would suffer higher casualties, is unacceptable. The Abrams is expensive to maintain, but cheap compared to losing tank crews. The tank that Soviet generals mocked outlived the Soviet Union itself. The USSR dissolved in December 1991, less than a year after Desert Storm. The Abrams continues serving today, more capable than ever, still the standard against which all other tanks are measured. The gas guzzler is still hungry for fuel. The overcomplicated systems still require extensive maintenance. The overweight platform still challenges logistics. But none of that matters when the tank does its job better than any alternative. Soviet skeptics were right that the Abrams made compromises. They were wrong about which compromises mattered in combat. Technology, training, and crew survivability proved more important than simplicity and fuel efficiency. Quality defeated quantity. The future defeated the past. And the tank they laughed at helped end the Cold War by demonstrating that Soviet military power, which had seemed so formidable on parade grounds and paper, couldn't survive contact with modern Western technology. They gathered in Moscow conference rooms in the 1980s, Soviet generals and intelligence analysts, studying photographs and technical specifications of a new American tank. They saw the weight, the fuel consumption, the complexity, and they laughed. Overengineered American excess, they said. Too sophisticated for real war. They believed their T-72s, simple and reliable, producible in thousands, would overwhelm Western technology through numbers and tactical skill. They believed Soviet doctrine, proven in the Great Patriotic War, would prevail again. Then came the desert, the sandstorm, the thermal imaging that saw through darkness and dust as clearly as daylight, the fire control that turned gunnery into science, the armor that couldn't be penetrated, the mobility that couldn't be matched. Iraqi T-72 crews, trained by Soviets, fighting with Soviet doctrine, equipped with Soviet weapons, discovered what their trainers had refused to believe. The Abrams wasn't just better. It was untouchable. 23 minutes of combat at 73 Easting. 28 Iraqi tanks destroyed. 0 American losses. Repeated across 100 battlefields. Thousands of Soviet-designed tanks destroyed. Not one Abrams lost to enemy tank fire. The Soviet Union dissolved within months. The generals who'd mocked the Abrams watched their empire crumble, their military doctrine obsoleted, their certainties shattered. The M1 Abrams didn't just survive combat. It redefined what modern armored warfare looked like. It proved that technology and training could overcome numerical superiority. It demonstrated that protecting your soldiers mattered more than producing cheap, expendable weapons. For decades later, it's still rolling, still dominant, still setting the standard. Upgraded, modernized, continuously improved, but fundamentally the same tank that Soviet generals dismissed as impractical. They mocked its weight, but that weight carried armor that couldn't be pierced. They mocked its complexity, but that complexity made it unstoppable. They mocked its fuel consumption, but American logistics fed it, and it never stopped advancing. The tank the Soviets laughed at outlived the Soviet Union and buried its military legacy beneath its tracks. From mockery to myth, from skepticism to legend, the M1 Abrams. Untouchable, unmatched, undeniable.